Hello, today's lesson is a review of polar coordinates. So we're going to start, I've got two separate videos. This one is just about polar coordinates. We're going to be plotting points and we're going to be converting, no, we're just going to be plotting points in this first one. In the second video, we will be converting points between polar and rectangular from polar equations to rectangular equations and back and the other way from rectangular to polar, polar to rectangular for equations and points in the next video, and a little smattering of calculus. So back to this one. This video is just about plotting points. So the first thing I want to do is I want you to actually turn the page so you're looking at the back of the first piece of paper, and I hope you recognize this is what your polar grid looks like. So all of these radian measures are not shown on the grid on the front. So I wanted you to see that we've got the ones that we know, obviously 0, pi over 2, pi, and 3 pi over 2. The next one people usually do are the pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And then from here, people usually go to the 3's. So we've got pi over 3, 2 pi over 3, 4 pi over 3, where's 5 pi over, sorry, 5 pi over, sorry, 4 pi over 3, 5 pi over 3. And from here, we get to the pi over 6's. So we have a pi over 6 here, we have another pi over 6 here, pi over 6 here, and pi over 6 here. And lastly, we have the pi over 12's, which we won't be using too often, but that's what those extra ones are that we haven't circled. So anyway, this one shows everything, and the one on the front doesn't. So if you need to reference this, please do so. Back to the front, we are going to go ahead, and I'm going to look, sorry, at a bigger view of that. Here we have a polar graph. What's on here is the suggestion in number 1, which is to take a piece of paper, an index card, and go ahead and label it with 0 right in the middle, and then you would label this as 1. This would be 2 right along the lines, sorry, the curves. 4, this is 5, this is 6, this is 7, all the way up to 10. And then down here are the negatives. So here we have -1, -2, -3, -4, -5. You're welcome to do that. If you aren't certain of how polar coordinates work, that will be a very helpful technique for you to use. If you're confident with polar coordinates and just need a little refresher, then you should be okay. So in number 1, it says that we're going to take a ruler and we're going to line it up with put the origin on 0, and we're just going to lay it across and then rotate it so that we're at pi over 3, excuse me. So pi over 3 again is up here. This is pi over 3. So what it's asking us to do is actually lay this out, and this is pi over 3, the ray, and then it says on this ray, draw the ray, which is pi over 3 right here, mark the point r comma theta at 7 pi over 3. So along this, we're just going to count out 7 circles. So 1, 2, 3, 4, 5, 6, 7. So there is the point 7 comma pi over 3. So 7 comma pi over 3. I'm going to end up doing some erasing on mine as I go when it gets a little too cluttered, but yours is going to show all of these points. So that's the point number 1. So now we're going to leave the number line ruler at the same spot, and we're going to go -8 units, which means instead of going sort of from the origin up, I'm going to go from the origin down. And again, my pi over 3 going down over here. So I'm going to count 8. 1, 2, 3, 4, 5, 6, 7, 8. And so this point is -8, me going backwards along pi over 3, and my angle, my theta, is pi over 3. Now we're going out to 4 pi over 3. So 4 pi over 3, basically from here to here is 3 pi over 3, because that's pi. and then we got to go one more. So one more is going to be right here, which is this red. This is going to be our 4 pi over 3 is the red. And then we're going to plot the point 4 pi over 3, 8. So at 4 pi over 3, I'm going to go out 8. 1, 2, 3, 4, 5, 6, 7, 8. And I land right on the same spot. So the coordinates for this point are also 8, comma, 4 pi over 3. So this point right now has two different sets of coordinates that identify the same point. Ultimately, with polars, there are infinitely many polar coordinates that will identify the same point. And then we have to do one more, which is -7, comma, 4 pi over 3. So along our 4 pi over 3, we're now going to go -7, which means I'm actually going backwards into the blue 7. 1, 2, 3, 4, 5, 6, 7. And I land on that spot again. So this point is -7, comma, 4 pi over 3 as well. Again, same point, two different names. Ultimately, there are infinitely many different names for each point. And so what do we notice about these? Well, they're the exact same spots that we were in for number 1. 1 and 2, excuse me. So now number 4, we're now going to go to 2 pi over 3. So 2 pi over 3, I'm going to do that one in black. 2 pi over 3 is right here. 2 pi over 3. And now we're going to mark the point 5, comma, 2 pi over 3, so I count out 5. And this is 5, comma, 2 pi over 3. And then we want to do -6, 2 pi over 3. So now I'm going to go backwards, pi over 3. And that's going to put me here. Sorry, continuing with my line. The benefit of you having a piece of paper to do this. I am now going to put it -6. 1, 2, 3, 4, 5, 6. So this is -6, comma, 2 pi over 3. Then we are going to do, I'm not doing the rest of number 4. So let's come up with another name though. What else could I have called this point where I've just put a black X with a circle around it? I could have used a negative angle, and if I'd used a negative angle going this way, that would be -pi over 3, and my radius would then be 6. So this is another name for this point. Another way that we could have done it is I could have done so this way was a positive radius and negative angle. We could also do it with a positive angle and a positive radius. This is where I'm going to start erasing what I have here. So if I go all the way around the circle this way, that's going to end up being, that's 3 pi over 3, 4 pi over 3, this is 5 pi over 3, and I would have +6, +5 pi over 3, and that's that same point. And again, all of these points, this one point is named by all these different ways. So I've kind of gone away from what was 5 and 6 because that was a different point. I just used the -6, 2/3 pi. Sorry, 2/3 pi. So I'm going to be finished with that first page, and now we're going to go 2 pages over, and we're on number 9. And we're going to plot and label these points. So I'm going to go ahead and just move my screen so I can see this. And point A is the point 2, comma, pi over 4. So I'm going to go to I'm going to go to pi over 4, which pi over 4 is right here. Starting at the origin, I'm going to go up to 1, 2. This is point A. Next point that I have point B, and that is at -2, comma, 5 pi over 4. So for 5 pi over 4, I'm starting here, I'm going 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 down here. So this is my angle that I'm using, and I'm going a negative radius, a -2, so I'm going backwards, 1, 2, and this is point B as well. So A and B end up indicating the same point in polar coordinates. Next point is C. C is at the point 0, comma, pi. Now, when my radius is 0, that means I'm not moving away from the origin at all, and I'm going to be on the pi, which here's my pi, is in red, pi is right here, but my radius is 0, which means I am right at the origin in red. The next point that I have is E, and E, sorry, E is not the next point, D is the next point. My apologies. D is at the point -1, negative pi. So negative pi takes me around to here, same as positive pi. And I want to go a -1, which means I back up 1. So here I am at point D. Now the next point that I have is at E. E is at 1, comma, 0. So that means my radius is 1, but my angle is 0. So I'm not going anywhere, but I am going out 1. So I have my radius of 1, angle 0 ends up right on top of D. Hopefully those were all good. We're now going to move on to the problem at the bottom, number 10. I'm going to leave my grid right here so that we can see it. And in number 10, it asks me the rectangular point. So in rectangular Cartesian, the way we always used to do coordinates, I'm at 0, comma, -1, and we need to find all the equivalent polar names. So first of all, I'm going to go ahead and plot this 0, -1. And 0, -1 is literally 0, my x is 0, and then I go down 1. So this point in rectangular is 0, comma, -1. So once we've identified that, it's fairly easy to go through all of the answer choices to decide if this given polar coordinate in 10, A, B, C, D, E, F, G, H matches with this rectangular coordinate 0, comma, -1. So let's start with the first one. The first point, A, is -1, comma, 3 pi over 2. That's 2. So my angle is 3 pi over 2, so that's going to be 1 pi over 2, 2 pi over 2, 3 pi over 2. And I'm going to go -1, which means I would go backwards. So here is answer choice A, and that is not the same point. So A is not an option. Let's move on to B. B is at 1, comma, 3 pi over 2. So again, I follow this blue 3 pi over 2 all the way around, and then I go down 1, and that ends up putting an X right on the spot. So that is the same point as rectangular 0, -1. Moving on to C. C is at -1, comma, -pi over 2. So let's figure out where -pi over 2 is. -pi over 2 is this way, towards pi over 2. So that's my angle, and I'm going to go -1, which means I'm going backwards, and I'm right on point A. So that is not the same as rectangular point 0, -1. Moving on to D. D is at -1, positive pi over 2. So for positive pi over 2, I come to this pole, and I'm going to go a -1, and that puts me right on the spot. So D is a correct answer choice. So from here, I am moving to part E. And in part E, I'm at the point 1, comma, 7 pi over 2. So we can count our pi over 2's unless we know where 7 pi over 2 is. And if you don't, just count. So I'm just going to go ahead and count. I've got 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So this is 7 pi over 2. Moving on from 7 pi over 2, I need to go a +1, which puts me on the same spot. So I like E. E is the same. F is at 1, comma, -pi over 2. So I've got a negative pi over 2 coming down pi over 2, and I want a positive 1. That puts me right on the spot. F works. G is at negative 1 comma negative 3 pi over 2. So for negative 3 pi over 2, let me get some of this stuff out of here. Sorry. For negative 3 pi over 2, I'm going 1 pi over 2, 2 pi over 2, 3 pi over 2. So here I am. I'm going to go negative 1 from the origin. That puts me down here at the bottom again, and I am at G is at the same point as rectangular point 0, negative 1. Next, we have H, which is at 1 comma negative 3 pi over 2. So again, I've got the same angle. I'm with the red that I had just drawn. So this is my pole. I'm at negative 3 pi over 2 and a positive 1, which puts me up here. H is no good. So at this point, this is the video for the review of the coordinates, and you will need to watch the next video to talk more about converting between polar and rectangular and a splash of calculus. Thank you for watching. Have a great evening.